Thanks, Sarah. Hey, everybody. How's it going? Thank you so much for being here. Today, I want to talk about my research on how knowledge graphs and LangSmith evaluators can help improve the efficiency of a RAG system. So imagine you're building a RAG system for healthcare building codes, and the model can confidently returns an answer about the number of consultation rooms required. But how do you know if it's actually correct? And the reason I bring this up is because FGI guidelines is something that we designers use to design a hospital building. And so the data in this book is so nuanced that every time the designer designs the building, we have to go to each of these sections. And it's nuanced in a way that sometimes the sections asks you to go look at other sections. And so some of the typical queries of what designers would use this book as, for example, the consultation rooms. The answer is 13, but it is a math question. And so you want the LLM or the RAG system to combine the two answers. And so the current RAG systems today are pretty good in retrieving relevant context, right? They're good in generating fluent responses with the help of LLMs. But how do we actually verify its accuracy? And it's critical, especially in healthcare building codes, because sometimes these errors can cost millions of dollars in construction costs. And so in this presentation, we'll look at different indexing strategies, LangSmith's role in testing, the evaluation workflow, types of evaluation data, types of evaluators, and some practical experiments and results. So for indexing strategies, I use three different types of strategies. The first one is the most basic one that you all know about, which is the text splitter. So basically dividing the document into chunks with 1,000 characters and a split of 200 overlap and saving that in the Neo4j vector database. The second strategy that I use is a Raptor technique, wherein the documents are divided into chunks, which is saved in the database. But the chunks are grouped into clusters and summarized, and each of these summaries are then saved in the database. But the summaries are then grouped and further summarized as the main summary, and put that in the same database. So it's like three layers of data that's added as nodes in the vector database. And lastly, the LLM-based graph transformer indexing, wherein you take the document, you divide it into chunks, and these chunks are saved as nodes, which are then connected with the similarity relationship. And that is just one layer. But there's another layer where the chunks are then sent through the graph transformer with the help of LLMs to create entities and relationships, which are then connected to the nodes from the first level. And this kind of, again, makes it more multi-directional. And the reason this is good because, like I showed before in the code book, the data is not linear. It's multi-directional. You would have to go and check in different sections. And so I feel like this was another good indexing strategy. And so now we come down to LangSmith. So what is LangSmith? So LangSmith is an online platform that helps with debugging, collaborating, testing, and monitoring LLM applications. And what does that actually mean, right? And before we go to that, I want to talk about three terminologies that is used in LangSmith a lot, and that's run, trace, and a project. So as you can see, the run, the bottommost, is a single unit of work. So every time, for example, in an app, a question is asked, and the question is then the question is then used to retrieve data from the retriever. So that is one run, and so on and so forth. And a collection of these runs becomes a trace, and a collection of trace becomes a project. But what does this all mean? Let me show you an example. So this is a dashboard on LangSmith. As you can see, this is a project called Hospital Code, and each of these rows are traces, and the traces have runs within them. LangSmith is good because now you can check if the trace has thrown an error. As you can tell in the first four rows, there has been some kind of an error. Or you can also verify if whether the data that was retrieved from the retrievers was accurate. So this is like the basic dashboard on LangSmith. And so if you were to click on one of those rows, you can see one of those traces, which is a row. You can see all the runs that has been done on the back end once the question was asked. So in this case, on the right, you can see the question was, are handrails required in hospital corridors? And so once you ask the question, and every step the app takes to get to the answer can be checked on the back end to see if it was done right. So this was the question. We can then look at what the prompt template is for the LLM. And in this case, I used OpenAI. We can look at also the data from the vector stores that have been acquired. This is also based on how many sets of data that you want, and you can control that. I think in this case, I've set 5, and you can also go through that. And finally, you can look at how the data along with the question was put into the prompt template and then sent into OpenAI for further answering the question, and then you see the final answer. So this is what LangSmith does. So every time you ask a question, it goes through multiple different runs, and that becomes a trace, and the trace becomes the actual project. So basically, it's giving you more granular approach to how you can control what the output is. And that's what LangSmith does and helps quite a bit. So let's talk about some of the evaluation workflows that exist. But the one that I'm using is the one that is inbuilt with LangSmith, and it's something like this. So you have a data set, and when I mean data set, you have a list of questions and answers, and that is the ground truth. And so every time to test the authenticity of the RAG app, you send the same question from the data set to the RAG app, and you get an answer, as you can see on the right side. But the workflow also takes in the answer from the ground truth and then sends it to the LLM as a judge. So this, I'm sure there are multiple different ways to evaluate the authenticity and verify the answers. So in this case, this is known as LLM as a judge, and using ground truth or data sets as the way to verify the authenticity of the answers. And so there are different types of data sets that LangSmith allows you to put in. One of them is the developer created questions, wherein it's a key value pair. There are custom questions and answers related to the data and the vector store. They're highly curated. They're also manually created. For example, as you can see, the question of how many consultation rooms, and that is the right answer. So if you're testing the RAG app with this data set, it should be 13. Anything beyond that, is wrong. So these are developer created questions. You also have user questions. For example, you may have a RAG app that is used in production right now. And when the users ask for questions and answers, you can save, as you can see on the bottom left, you can save the question and the chat history as a means of ground truth, which the RAG app can later be evaluated against. And the last one is the synthetic data, which is LLM created data sets. So 3 types of data sets. And so going back to what the workflow looks like. So you have 3 different types of data sets. You can choose to put any one of them, or you can have all 3. And that acts as the ground truth when you're sending it into the LLM which acts as a judge. And the final output, as you can see on the right side, you get two metrics. One is the score and one is the key, which is the type of evaluators. So this is like the basic workflow that LangSmith kind of looks at. And so there are 4 different kinds of evaluators. And in this case, there's document relevance, answer faithfulness, answer helpfulness, and answer correctness. So all of these are used with LLM as a judge, and you provide the prompt to the LLM to perform these evaluations. And what are those prompts, you ask? I'll tell you. So document relevance, and this is the prompt that you get. So all of these are available on the thing called Hub within LangChain. As you can see on the bottom of the screen, that is the code to pull in the prompt directly into your eval code. And so this is the document relevance, wherein it checks for the facts that are related to the question. So it checks for all of the data that's been retrieved from the vector store in relation to the question. Faithfulness looks at hallucination and see if the facts are grounded, again, in comparison to the question answer data set that it's comparing against. Answer helpfulness looks at how concise is the answer, because sometimes you ask for a lot of context coming in, and so you would want the LLM to give the right amount of data, and so this checks for that. And the last one is correctness in terms of how factually accurate it is, or how close is it to the key value pairs in the data sets that we have. So four different types of evaluators. And so the evaluation workflow essentially looks like this. So you have different types of data sets, and you have different types of indexing strategies in the bottom. Well, obviously, I'm doing this because I want to try and see which works the best. And then you have four different evaluators for the LLM as a judge. So this would be what the workflow would look like when using LangChain as an evaluator. So I want to share some of the outputs based off of the experiments that I did. And so for the first one, I want to talk about text splitter, using text splitter as a vector database. And oh no, I'm using Neo4j as vector database, but using text splitter as an indexing strategy. And so once you do all those runs, you get this dashboard wherein you can get all of the graphs. So there are four different graphs based on what we spoke about, the four different evaluators. So document relevance, answer hallucination, answer helpfulness score, and answer reference. So each dot on the graph is the run that has happened. So I've done two runs for each of these, and as you can tell, the score is pretty bad, and I'll tell you why. So, to the original question of how many consultation rooms were required for behavioral and mental health facility with 152 beds, as per that section, it does not actually verify that it's 13. It just says you need 12 beds per room, right? And so it's basically a math question for the LLM to figure out, which that's why I feel like it kind of failed. And so on the right side, you can see the reference input and the output, and that is obtained from the data set, the key value pairs. And the output is what the RAG app or the RAG system is providing in terms of an answer. And so obviously it does not match with the output, right? And so at the bottom of the screen, you can look at what the document relevance was zero. The scale is 0 to 1, again, was 0.0 to 1.0. And it also shows how many tokens was used and if it was a success. Well, it's a success that it went through with the answer, but it was zero and it kind of failed because it didn't give the right answer. And so we have answer faithfulness, which shows 1 in this, but it's not close to what we want. It just is the right section that it found. Answer helpfulness does not give the right answer, and answer correctness also does not give the right answer. So that was text splitter. In terms of Raptor as a indexing strategy, again, the same kind of dashboard with the four different graphs. This kind of failed too, for the most part. Uh, answer faithfulness, answer helpfulness. It kind of gives answers related to the section, but not the actual answer that you want. Answer correctness also. So all of these are zeros. And the last one is the LLM graph transformer, which I think worked the best. So in terms of document relevance, it was a zero. But in terms of answer helpfulness was a zero as well. But in terms of answer correctness, it came close. It got the number 10, which I think is wrong because it should be 12. But it did the math and was close to giving the answer. So, it was close, but not exactly accurate. But the whole point of these evaluators is to try and analyze and see what systems, what indexing systems work well, what kind of chunking works well. And so I think in my case, they all failed. I definitely have to go back and find a better way to index the entire book. Thank you.